Neobehaviorism developed during a time when psychology was striving to establish itself as a hard science. Early behaviorism and early behaviorists like Watson rejected mental processes entirely, insisting that only stimulus-response patterns mattered. However, this overly strict approach could not explain certain observations, such as learning without reinforcement, purposeful behavior, and internal states like motivation. Neo-behaviorists such as Tolman, Hall, and Skinner sought to preserve the strengths of behaviorism: objectivity, measurable data, and experimental control, while introducing scientifically acceptable ways to discuss internal factors like drives, cognitive maps, and intervening variables. This movement laid a foundation for the eventual rise of cognitive psychology. Neo-behaviorism believed that psychology must remain grounded in things that can be measured. For an idea to count as scientific, it needed an operational definition, meaning it had to be defined by the procedures used to measure it. This prevented vague, untestable concepts from being included. Many neo-behaviorists accepted intervening variables, such as motivation, habit strength, drive, or cognitive maps, but only if these could be tied to observable behavior. The goal was to maintain scientific rigor without ignoring internal processes altogether. Controlled experiments using animals, especially rats and pigeons, became central to neo-behaviorist methodology, allowing researchers to analyze learning mechanisms with precision. Tolman challenged the idea that behavior is simply a chain of conditioned responses. He argued that organisms act with purpose. They engage in behavior to achieve goals. This set Tolman apart from strict S to R theorists. His concept of cognitive maps emerged from experiments, showing that rats learn maze layouts even without rewards. This demonstrated that animals form internal mental representations of space, something classical behaviorists denied was possible. Tolman also introduced latent learning, showing that learning can occur without reinforcement and only become visible once a reward is introduced. This significantly weakened the claim that reinforcement is necessary for learning. Tolman's research demonstrated that reinforcement does not explain all learning. His latent learning experiment showed that rats that freely explored a maze without reward later ran it just as efficiently as reinforced rats once rewards became available. This meant learning had occurred silently in the background. His cognitive maps proved that animals and humans build internal models of their environment. This was a major step towards cognitive psychology because it implied that mental structures, even if unobservable, played a functional role in behavior. Tolman's emphasis on purpose, expectation, and internal processes made him a transitional figure connecting behaviorism to the emerging cognitive revolution of the 1950s and 1960s. Hull attempted to turn psychology into a mathematically predictive science. He believed behavior was driven by biological needs, such as hunger or thirst, that create internal drive states. When a behavior reduces a drive, for example, eating reduces hunger, reinforcement occurs. Hull's system incorporated hypothetico-deductive reasoning, meaning he generated theories that produced testable predictions. His formulas attempted to quantify habit strength, drive levels, and the likelihood of behavior occurring. Although many of his formulas did not withstand later scrutiny, Hull's ambition to mathematically model learning influenced later fields such as computational modeling and cognitive science. Hull's formulas were among the first attempts to mathematically predict complex behavior. His drive reduction theory argued that reinforcement strengthens the connection between a stimulus and response by satisfying a biological need. Habit strength became a key idea, referring to how well practiced a behavior was. According to Hull, the stronger the habit, the more likely the behavior would occur. Although later psychologists criticized his formulas for being overly rigid, Hull's work pushed psychology to adopt more precise and quantitative methods. This framework laid intellectual groundwork for later computational theories of cognition. Skinner represented a more radical form of neobehaviorism. Unlike Hull or Tolman, he rejected internal states altogether and insisted that behavior is controlled entirely by its consequences. His operant conditioning framework proposed that behaviors followed by reinforcement increase in frequency, while behaviors followed by punishment decrease. This approach became one of the most influential learning theories in psychology. The operant conditioning chamber, also known as the Skinner box, allowed precise measurement of how reinforcement schedules affect behavior. Skinner's strictly empirical approach made his work central in experimental psychology and the treatment of behavior problems. Skinner's biggest contribution was his detailed analysis of reinforcement. His schedules of reinforcement, fixed ratio, variable ratio, fixed interval, variable interval, explained how behavior patterns develop and persist. Shaping involves reinforcing small steps toward a larger goal behavior, making it possible to train complex actions in both animals and humans. Skinner's work laid the foundation for applied behavior analysis, or ABA, which is widely used in clinical settings, education, developmental psychology, and interventions for autism. His theories remain highly influential today. Although Tolman, Hall, and Skinner differed significantly in their approaches, they shared key principles. All believed that psychology must remain empirical and grounded in observable behavior. However, unlike Watson, they accepted the idea that internal processes could be scientifically meaningful if they were tied to observable outcomes. New behaviorists used rigorous experiments, especially maze learning, operant condition chambers, and controlled reinforcement schedules, to understand learning mechanisms. Their collective work helped psychology mature as a scientific discipline and establish methodologies still used today. Neobehaviorism laid the groundwork for the cognitive revolution by demonstrating that internal processes could be studied scientifically. Tolman's cognitive maps, Hull's quantitative modeling, and Skinner's reinforcement principles all shaped how psychologists approach learning and motivation today. The movement also strengthened experimental methods, operational definitions, hypothesis testing, and precise measurements became standard. Modern applications include behavioral therapy, education systems, organizational training, artificial intelligence, reinforcement learning, and decision-making research. Neo-behaviorism remains one of the most influential chapters in the history of psychology.